All right, so starting chemistry today. So I've posted a chemistry equation sheet. So the last two chapters of the semester are all about chemistry. So we have some equations we're going to be using when we get into some of the example problems, but we're also going to be using the periodic table quite a bit. So I posted a periodic table as well, just like this guy here. So I have not posted the questions yet for this chapter, but what we have to do this week Sunday, just like everything else all the time. You'll have a set of chapter 7 homework quiz. And it's part 1. So chapter 7 is kind of a big chapter. So you're going to have 2 different homework assignments for it. So the part 1 homework assignment is going to be due this Sunday. And then next Sunday, it's going to be another chapter 7 homework quiz, but part 2 on the second half of that chapter. Also, don't forget about your discussions as well. So with chemistry, we're looking at the periodic table, elements. We are also looking at atoms. So I have posted 2 PowerPoint videos. The reason I posted 2 is so they're shorter, so that hopefully people actually watch them. I feel like the longer ones, people get bored and stop watching less than halfway through. So I broke it up a little bit so that hopefully it's a little bit easier to digest that way. So in those videos, I go through a lot of the concepts. And so I'm going to be applying those concepts here. So looking at elements, the definition of an element, that's all of those guys on the periodic table. Carbon, oxygen, copper, those are all elements. And what elements are made up of are atoms. So we're looking a lot in this chapter of the structure of an atom and what an atom consists of. So an atom has this center called the nucleus. Now this center has protons and neutrons in it. So what are protons and neutrons? They are called subatomic particles. So we have our protons and neutrons in the nucleus. Now surrounding that nucleus, there's this big cloud, and it's called an electron cloud because there's another subatomic particle that circles the nucleus, and these guys are called electrons, E-1. So we have electrons surrounding the nucleus. They have a charge of -1. So that's why I represent them with this E-1 symbol. We have protons that are in the nucleus. They have a charge of +1. So that's why they're represented with a P+. And we have neutrons as well in the nucleus along with the protons. And these are neutral, hence the name neutrons, so no charge. So what you need to know about elements is that they're made up of atoms. What you need to know about atoms is that atoms are made up of 3 subatomic particles: electrons, protons, and neutrons. Electrons have a negative charge, protons a +1 charge, neutrons neutral. Now, you also need to know masses. When we're looking at the mass of these particles, electrons, they have such a small mass that we just say it's 0, okay, no mass. For protons, they have a mass of 1. So I'm writing AMU. What that means is atomic mass units. Okay, so they have a mass of 1. Neutrons with no charge also have a mass of 1. What this is saying is that most of the mass of an atom is located in the nucleus because the protons and neutrons, the only 2 of the subatomic particles that have mass, are located in the nucleus. Now the nucleus itself, with the protons and neutrons in it, we have the neutrons with no charge and the protons with a +1 charge. So the nucleus's overall charge is positive because of those protons. And since electrons are negative, they're attracted to that positive center. So opposites attract. Positive and negative are attracted to each other. So the reason these electrons are orbiting or circling the nucleus is because of that attraction between the opposite charges. So we're going to use this mass information to do some mass calculations. So, there's this top part. So mass, to calculate our mass numbers, we're going to be adding the protons plus the neutrons. So when you are given particle counts, and by particle counts I mean if you are given the number of electrons, protons, and neutrons of a particular atom, you need to be able to calculate the mass number of that atom. And when we're calculating mass, remember, electrons don't count. So it's just the protons and neutrons that are going to matter. So why do we want to calculate mass number? We calculate mass number in relation to isotopes. So what an isotope is, atoms of the same element with different mass numbers. So we calculate mass number of isotopes because, so let's look at the word isotope. If you have carbon atoms, for instance, so carbon's an element, elements are made of atoms. So if you have carbon atoms, some of those atoms will have a mass of 12, but some of them will have a mass of 11. That's what isotopes are. So we have carbon 12 and we have carbon 13. So these are carbon element. They represent carbon atoms with different mass numbers. So this number here, that is the mass number. These are two different ways to represent isotopes. One is by writing the element name, carbon, in this case, and then dash, and what comes after the dash is the mass number. So that's one representation of writing an isotope. This other representation up here, this is the same isotope, it's carbon 12, but it's written in a different way. So this form here is called a nuclide symbol. That's the other way that we represent an isotope, nuclide symbol. For a nuclide symbol, we have the element symbol, carbon in this case, in the center. So that's what this X is representing, the element symbol. And then in this upper left-hand corner, we have the mass number. Oftentimes, when people represent an isotope as a nuclide symbol, they have this mass number in the upper left-hand corner. Sometimes they also put the atomic number down here. So what is the atomic number? Well, let's look at our periodic table. So given the periodic table, since we're talking about carbon, if I find carbon on the periodic table, it is right here in group 14, it's number 6. On the periodic table, this is what carbon looks like. I have C, then the name carbon written under it, 12.01 written here, and then a 6 up here. So looking at how carbon is represented on the periodic table, this number 6, that's my atomic number. The atomic number tells me how many protons carbon atoms have. So this number 6 says there are 6 protons in every carbon atom. This letter C, that's my atomic symbol. that I would put here when writing as a nuclide symbol. And then this 12.01, this is my average atomic mass. Average atomic mass is different than mass number. Mass number is a whole number that you calculate by adding the protons of that particular atom to the neutrons in that particular atom. The average atomic mass, you'll see by looking at the periodic table, is always a decimal point number. Okay? It's not a whole number. So that's how you can tell the difference between those two. So using this information are two different ways to represent isotopes. We're going to look at some problems where we are given the protons, the neutrons, possibly the electrons, and we're going to come up with the nuclide symbols for them, how to represent them. So some of the problems that were given on the PowerPoints, for instance, if you are given the atom counts, let's start with atom counts. We're given 82 protons, 82 electrons, and 125 neutrons. What we're going to do with this information is we're going to calculate the mass number, and we are going to represent this particular isotope as a nuclide symbol. So, these numbers, these subatomic particles, they're telling us, given an atom, here's my structure of an atom, the nucleus in the center, and then we have the rings around it where the electrons are. So they're saying that there's 82 protons in that nucleus, there are 125 neutrons in that nucleus, and then there are 82 electrons on these outer levels orbiting. Okay, so just so you can get a picture of what they're trying to describe here. What we're going to do with those numbers is we're going to use our mass number calculation to figure out the total mass of this particular atom. And remember, for mass, we said that only the protons and neutrons count towards mass. The electrons don't. So if you are given the electrons, don't count them towards mass. Okay? That's just an extra piece of information. So to calculate the total mass, we'll take the protons, 82, and add the neutrons, 125. Calculate that correctly? So the total mass of this particular atom is 207. All right, well, how am I going to represent it as a nuclide symbol? Well, to represent it in a nuclide symbol, I need to know what element I'm talking about because we need to put the element symbol here. So how do I figure out what element they're describing here? The piece of information that's going to point you to what element is always going to be the number of protons. The number of protons will identify the element because the number of protons is the same as the atomic number. So all you have to do to figure out what element we're talking about is look at the number of protons. I have 82. What that means is the element number, the atomic number, is going to be 82. So you go to your periodic table and you find number 82. And number 82 is lead. You should see this if you're looking at your periodic table. 82, and it's Pb, lead, and the average atomic mass is written there as well. So this is how it looks on the periodic table. So the reason I needed to look this up and match up this protons with the atomic number is because when I write the nuclide symbol, what goes in this X spot is the symbol on the periodic table. So PB is how I'm going to start my nuclide symbol. The number that goes in this upper left-hand corner, it is not the average atomic mass on the periodic table. It's the mass we calculated using just the protons and the neutrons. So the mass number of 207 in this case is going to go up here. If you want, you can put the atomic number of protons down here, but you don't have to. That's optional. So this would be the correct nuclide symbol of that particular element, of that particular atom, I should say. All right, so let's do another one doing all those same steps. So I'm going to give a new particle count. The next particle count is 50 protons, 50 electrons, and 119 neutrons. So new atom. If I wanted to calculate the mass number, I need just the protons and neutrons. Just this number and that number. So my total mass number, 50 plus 119, 169. Now to represent this as a nuclide symbol, I got to figure out what element that is. To figure out what element that is, I'm using the number of protons, 50 in this case, to find it on the periodic table. So I'm looking for number 50 on the periodic table. Number 50 is 10. Is that right? So 10 is number 50. So this is what it looks like on the periodic table. To represent it as a nuclide symbol, I'm going to take that SN. And in the upper left-hand corner, I'm going to put the total mass number that we calculated, 169. And down here, optionally, I can put that 50 that we used to find that symbol itself. All right, so what other types of problems are you going to see using mass number and nuclide symbols? Well, let's look. Now we're going to do how many neutrons? So given that we have a sodium atom with a mass number 23. Okay. Question is saying calculate the neutrons. We have a sodium atom with a mass of 23. So we're still using this mass number equation. It's just this time we're solving for neutrons. Well, they gave us the mass number. It's 23. But we also need the number of protons. So how do we figure out the number of protons? Remember, the number of protons tells us the identity of the element. They didn't give us the number of protons, but they did give us the identity of the element. It's sodium. So find sodium on your periodic table. Sodium, it's a little hard to find because sodium is actually Na is its symbol. So sodium is number 11. Looks like this on the periodic table. And remember, this decimal point number, this is our average atomic mass. That's not going to help us in this case. What's going to help us is this number 11. This is the atomic mass. This is the number of protons. Okay, so we know it's sodium. We can find it on the periodic table to find our number of protons. So we have mass number 23. We have our number of protons, 11, so we can rearrange this equation to solve for the number of neutrons. So to solve for our neutrons, we take our mass number and subtract our number of protons from it. So our mass number they gave us in the question, they said it was 23. The number of protons, we found those by looking up sodium on the periodic table, 11. Subtracting those, we get 12 neutrons. So this particular atom has 11 protons and 12 neutrons. So let's try another one, calculating neutrons. So the next problem we're going to look at is a carbon atom with a mass number of 14. Very similar, carbon atom, mass number of 14. Same steps. We're solving for neutrons. We're going to take our mass number, which is given to us, and subtract the number of protons. They didn't give us the number of protons, but they did give us the identity of the element. It's carbon. So how many protons does carbon have? I look it up on the periodic table. It's number 6, and that number 6 is the atomic number, which is the number of protons. Carbon has 6 protons. Now I can plug in my 14 for mass number and my 6 for number of protons. We get a total of 8 neutrons. All right. Next, let's do an element with atomic number So now this one's not giving us the identity of the element. It's actually giving us the atomic number and the mass number. Well, what is atomic number? Atomic number is the number of protons. It is that number above the chemical symbol on the periodic table. So since the atomic number, 5, is the number of protons, we can plug that in here. The mass number they gave us of 11, we would plug in there. So they gave us all the information, they just used different terms. So the mass number we just said is 11. The atomic number, which is the same thing as the number of protons, is 5. So we would just take 11 minus 5 to get a total of 6 neutrons. What we're going to do is we're going to take this information and we're going to come up with the nuclide symbol. Remember when I said nuclide symbol, we write the element symbol here, we put the mass number in the upper left-hand corner, and optionally we can put the atomic number in the bottom left-hand corner. So how do I know what the element is? I look at the number of protons. That will tell me the identity of the element. We just said the number of protons, the atomic number is 5. So we look up 5 on the periodic table. What element is number 5? Boron, right. So our X, we're going to put a B for boron. The mass number, not the number of neutrons, it's not the atomic number, this guy here. So 11 is going to go up here. Optionally, we can put our number of protons here, number 5. This would be the nuclide symbol of that particular isotope that they just described there. So pretty much takes care of mass number. You're using protons and neutrons to calculate it, and you can thus rearrange it to solve for the number of neutrons as well. So the reason we need to know about mass number is because of isotopes, which we represent with nuclide symbols. Remember that isotopes are atoms of the same element with different mass numbers. What I'm going to do now, before we move on to the next topic, is I want to show you a pair of isotopes, and we're going to calculate the subatomic particles. So the protons, neutrons, and electrons. So let's do chlorine 35, chlorine 37. So what these are nuclide symbols. This is a pair of isotopes. So what I mean is it's two atoms of the same element, because they're both chlorine, with different mass numbers. What I'm going to do is I'm going to calculate the number of protons, electrons, and neutrons of each of these. And I'm going to do it using this mass number calculation. Okay, so for the number of protons, since I'm talking about the same element, I'm talking about chlorine in both these cases, the number of protons for both of these isotopes are going to be the same, because the protons identify the element, and the element is chlorine in this case. To figure out the number of protons, since it's not given to me in this nuclide symbol, I would look up chlorine on the periodic table. And chlorine is number 17. That number 17, that is the number of protons. So 17 protons for both. Well, what about electrons? Okay, well, we said protons have a charge of +1. Electrons have a charge of -1. So I'm going to use this to figure out how many electrons. These atoms are neutral. So what I mean by that is they don't have a charge on them. We'll actually talk about charged atoms later in the chapter. But right now there is no charge. You don't see a plus sign or a minus sign on either of these. So if they're neutral, what that means is the protons, my positively charged particles, are going to have to equal my electrons, my negatively charged particles. Whenever you have a neutral atom, the protons are going to equal the electrons. So if I know my protons, 17 in both cases, that means I need to have the same number of electrons so that those positive and negatives are canceling each other out, leaving no charge on either of those. 17, 17. Now for the one that you actually have to do a calculation on to figure out the neutrons. So we're using this mass number calculation to figure that out. When we rearranged it, when we solved for neutrons, we took mass number minus the protons. So looking at this nuclide symbol, that 35, that is my mass number. So to figure out the neutrons in this first isotope, I'm going to take 35 minus the number of protons, which we said were 17. All chlorine atoms have the same number of protons. That's the atomic number on the periodic table. So subtracting that, can't do that in my head. 18. Okay. Gives me a total of 18 neutrons. Now over here, for my chlorine 37 isotope, it's going to have a different number of neutrons because its mass number is different. Now we have a mass number of 37. So when I calculate my neutrons here, I'm using the same equation, but with 37 instead of 35. So 37 minus the protons, 17, gives me a total of 20 neutrons. So for the chemistry chapters, it is a lot about concepts. So I really, really encourage you to watch the PowerPoint, probably before watching the calculation videos, because it's going to make a lot more sense if you have the definitions of isotope and mass numbers and protons and neutrons already explained to you before having the calculations thrown at you. So what we're going to do now to end the class today is another calculation, but this time we're not doing it using the subatomic particles. We're not using protons, neutrons, and electrons. What we're going to look at is calculating molar mass. There's other words for this. Some people call it formula mass. Molecular weight is often used. So when we calculate molar mass, molecular weight, formula mass, all the same thing. What we're using now is looking at the periodic table. We focused so far on the atomic number, this number here. We said this was the number of protons. We used that to calculate mass number. To calculate molar mass, though, we're not looking at the atomic number. We're going to be focusing on this decimal point number down here. This is my average atomic mass. So we're using these values to calculate. So when we're looking at molar mass, we're going to be given chemical formulas. So for instance, one of the chemical formulas we're going to see is C6H12. So this is a chemical formula of a compound. It's saying that this compound has C, carbon, H, hydrogen, and O, oxygen in it. The compound is made up of those three elements. These numbers, these subscripts after the elements, represent the number of atoms of each. What that means is there are 6 carbons, 12 hydrogens, and 6 oxygens. So when we calculate molar mass, we're going to be using those subscripts to figure out the number of atoms of each element. We're then going to multiply that by the average atomic mass on the periodic table. So if I want to figure out the molar mass of this compound as a whole, I'm going to use the subscripts to figure out the number of atoms of each. And then I'm going to look up each of these elements on the periodic table and find what their average atomic mass is. So for carbon, we just said, based off this formula, there are 6 carbons. Well, if I look up carbon on the periodic table and find its average atomic mass, it gives me a mass of 12.01. Information is from the periodic table. For hydrogen, well, I already wrote what hydrogen looks like on the periodic table here, so I'm using this average atomic mass, 1.008. We're saying each of those hydrogen atoms has a mass of 1.008, but I have 12 of them, so I have to multiply it by 12. For oxygen, looking up its mass on the periodic table, I get 16. So for the molar mass of this entire compound, I'm going to multiply across and then add all those values together to get my total. So 72.06. total of 180. All right, so the units on this are going to be grams per mole, and I'll explain those units a little bit better when we do calculations once we talk about a mole. But for now, I just want to do a few more molar mass calculations so you kind of get a feel for the steps when you're calculating molar mass. Because we're eventually going to take the molar masses that we calculate and use them in further calculations. But I want to get this step solidified first. So let's put up another example and do the same steps. Number of atoms. Let's do this guy, HNO3. So if I needed to calculate the molar mass of HNO3, H being hydrogen, N being nitrogen, and then O being oxygen. So I'm going to go through and do these steps for each element. It's kind of helpful to write a list of all the elements present in that particular compound. And then in the next column, list how many atoms of each. So remember, to figure out how many atoms of each, we're looking at the subscript after each of these elements. So hydrogen. Notice this time there is no number after hydrogen. So if there is no number, it's because there's only one of them. Okay, so how many hydrogen atoms? Just one. We got nitrogen. No number after nitrogen either, so that means there's just one nitrogen atom. Oxygen has a number 3 after it, so that means there are 3 of them. Now for the second portion, we're going to take the number of atoms and we're going to multiply it by the average atomic mass of each of these elements. So we look these elements up on the periodic table. Hydrogen is 1.008. Nitrogen, I think it's 14.01. It is. And then oxygen is 16. Multiply across and then add them all together to get the total molar mass of that compound as a whole. If I don't, 40. Yeah. Okay. Getting a total of 63.02. My units are going to be grams per mole. All right, so let's try one more, and then we'll look at using these molar masses in calculations next video. So, I'm trying to come up with one here. S2Cl6. So S is sulfur, Cl is chlorine. So how I know that this is one element and not two is because this is a C with a lowercase letter after it. So if it's a capital letter with a lowercase, both of those together are just one element. So make a list of all elements present. So I have sulfur and I have chlorine. Sulfur, chlorine. How many atoms of each? We're looking at the subscripts. So 2 sulfurs, 6 chlorines. For the average atomic mass, we look these up on the periodic table. And sulfur is 32.07. Chlorine is 35. Yeah, 35.45. Play across and then add them together. 2 times 32.07. I get a total of 276.84. right, so be it for today's calculations, but the chemistry chapters are a lot more intensive than our last few physics ones. There's a lot more information in them, so there is going to be at least 2 videos of calculations per week now. So there'll be another one posted this week, and you can use both of them to help you complete the homework quiz. What we're going to focus on in the next video is using these molar masses that we've calculated and applying these equations to it. You can see in the equation sheet that I posted, a lot of these problems have molar mass in them. And that's what this is. This is the molar mass. So we're going to be using these values in these equations, taking it a step further.